All right, so 10.2. So what we did already was we learned how to factor out common factors. And it's foundational to all factoring out common factors. Next, then, we have to learn how to factor polynomials. And that polynomial could be a binomial, a trinomial, could be a four-termed polynomial, all kinds of different possibilities. Well, today we're going to factor trinomials, a polynomial with three terms, right? All right, well, a key concept in factoring trinomials is what involves number one. So number one, when multiplying two binomials, and take your blue here, middle term, the middle term is the sum of the outer terms, not the outer limits, and the inner terms. And inner in red there. Now, we already know this. Remember, last chapter, we multiplied binomials, right? And we learned that the way you multiply binomials is to distribute. I did mention to you some teachers like to teach the FOIL method, but that in reality, you might as well learn how to distribute on the easiest ones to binomials. So let me refresh your memory on multiplication. First thing you would do, don't write this in your notes, is front, oops, I want my black there, is front times front, correct? And you would get the x squared. Agreed? Okay, so that's already done for us. Front times front. Next would come front times back. Yes? So go ahead and take your pen here, and let's take that front x and multiply it times that back positive 2. These are the outer terms. Do you see how the front x is the outside one of the front, and the back positive 2 is the outside one of the second? Earth to daydreamers. Okay. Don't fall asleep now, because this is key to what we're going to do today. So hopefully you agree, in green, you get a positive 2x, yes? For the outers. And I'm going to come up here and write outer, right? Those are the outer terms. The front x times the outer positive 2. The next thing you would do in your distributing is you would now go to the negative 5 in the front, would you not? And you would multiply it times the front of the second one. Those in red are the inner terms, right? Aren't they on the inside? Right? They're the two interior ones, yes? And a negative 5 times an x in red is a negative 5x, yes? And now don't do this last one, but if we were multiplying it out, we would finish with saying negative 5 times a positive 2 is the negative 10 already on your paper. Agreed? Okay. So then you would write your final answer just like that, right? X squared minus 3x equals 10. And how did you get your minus 3x? Take your blue and box in the two middle things. The outer times the outer plus the inner times the inner gives you that middle negative 3x. Yes? That middle term, that negative 3x, is the key to getting the correct factors. Let me say it again. That middle term, that negative 3x, is the key to getting the correct factors. And you must always make sure that the factors you chose create the correct middle term of negative 3x. It's the key to factoring trinomials. The key. So I'll show you how it applies here in just a moment. All right, so what's next? Remember, Factoring is unmultiplying. Factoring is unmultiplying. And as I just told you a minute ago, the key is making sure that your choice results in the correct, and I'm going to blue again here, middle term. That negative 3x. You got to end up with the negative 3x. You got to. And if you don't have the correct factoring. Look, here's the analogy. Let's just take a straight number. Let's factor the number 10. Real easy. Can I factor the number 10 into a 3 times 5? No, because 3 times 5 isn't 10. We didn't end up with the correct thing. Well, we're going to have possibilities here, and we got to make sure we get that correct middle term. I'll make that hopefully clearer here as we get to some examples. All right, what's this method called? The method of factoring trinomials is called this. And now look, is it any big deal that you know the name of a method? And the answer is not necessarily, except for this reason. When you go to factor a trinomial, do you not have to remember how to do so? Yes, right? If you go to factor a trinomial, you have to remember, how do I do it? By knowing the name of a method, if you can remember the name, then maybe you'll remember the method. Because the name is how you factor it. So in reality, knowing what it's called does become important because it should be your first thoughts. For example, here you are, 3 years from now, you're at a high school taking the SAT test to get into college. And the thing says factor, and you look and it's a trinomial, and you start saying, huh? What? Or you say, oh, trial and error. Yeah, trial and error. And you start factoring. And that's the method, trial and error. Now here's the problem. Here's the problem. Especially in 2015, here's the problem. Students want everything, and they want it as quickly as possible, and they want to do as little work as possible. Now, I should say that's a big generalization. That's pretty accurate. Trial and error is simply like this. Let's see. You can catch, I know, you play baseball. Ethan, go ahead and unlock my door to my room here. All right, here comes trial and error. So he's got my key ring. Go ahead and unlock my door. Okay. Key 1 didn't work. Unlock my door. Key 2 didn't work. Unlock my door. Key 3 didn't work. Unlock my door. This is exactly the situation. Key 4 didn't work. Unlock my door. Key 5 didn't work. Unlock my door. You won't have to do this many tries, though. And if he's systematic, he'll finally get to the key. Key 6 didn't work. I have a lot of keys on there, by the way, unfortunately. All right, Ethan, as your teacher, let me help you out. I know my keys. Let's try. How about try that one? I'll help you out because I have some knowledge. Did you unlock it? I heard that. Awesome. That was trial and error, right? That was trial and error. Now look, he could have had a little bit of discernment and could have said, oh, Ford. The door is not a Ford, so I'm not going to use that key. Nissan. Ford, the door's not a Nissan. I'm not going to use that key. That doesn't look like a door key. I'm not going to use that. And you could have had some things to help you narrow down, right? Well, that's what we need to learn. We need to learn some things that can eliminate some of the possibilities and make the trial and error with just a couple things. And my hope is you get good enough, you only need to do one trial. And you can be there. It's not hard. So let's figure out how to do it. All right. First off, when factoring, always look to lesson 10.1. Factor out common. Boy, that's ugly. Factor out common factors first. And folks, first is first. All right, can't tell you how many times I've said factor out common factors first. Factor out common factors first. Factor out common factors first. Oh, you forgot to factor out common factors first. Oh, you didn't factor out common factors first. See here, you didn't factor out common factors first. And students still forget to factor out common factors first. And I finally figured out why they still forget. Here's the main reason. You don't always have common factors. And because they're not always there, students can tend to forget about them. And I'm going to try my best not to let you forget about them. So just because they're not always there doesn't mean you can forget about them. It's got to be your first thought. So next thing says every polynomial won't have them. But you must look. You got to 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 look. That's got to be your first thought. So look, I'm trying to give you the thoughts to solve factoring polynomials. If you come across a polynomial, your first thought is, I'm going to use trial and error. Your second thought is, I'm going to look to factor out common factors first. That's what your brain should be saying. Now, here's the reality. No matter what your intelligence quotient, IQ, no matter what, the person with the lowest intelligence quotient in this room has a high enough intelligence quotient to memorize trial and error, factor out common factors first. There's not a person in here that doesn't have the necessary intelligence to remember those two things. But I'm telling you, it's the key to it all. And those are the thoughts you need to have. And if you have those two thoughts, I think we can get you where you need to be. So it's really important. That's why I boxed it in there. And we're going to just shorten it and use the front letters, right, to keep reminding us. So I'll say FOCFF, right? And hopefully that'll trigger factor out common factors first. All right, that's going to lead us then to our first example. So let me get that out of the way, and let's get our first example up here. All right, so here's a normal problem. Factor x squared minus 3x minus 10. All right, I probably should have used my shade here, but oh well, it's gone. I'm not going to worry about it. Number one, on the right, I gave you a rundown of what you should be thinking. Your first thought, you don't need to circle it. I'm just trying to focus your attention. Hey, look to factor out common factors first. So you look at the original polynomial. Are there any common factors? No, right? Lesson 1, you guys remember? Some of you are looking at me like you don't understand. Remember lesson 1? Common factor in each of the three terms? Does any of the three terms have a common factor? And the answer is no. But you know what? You had to look. So I'm going to write none. I thought of it. Again, I finally figured out why do students forget to do it? Because not every polynomial has common factors. And so then they tend to forget to even look. Don't do that, first thought. Okay, number 2, what's next? Our next is going to be our first try. So take your black and underneath write 2 parentheses. A trinomial factors into 2 binomials. If it factors. By the way, will every trinomial factor? No. If it doesn't, we would say it's prime, right? Now, pretty much most of them we're going to give you are going to factor because we want to teach you and want you to practice on factoring. Okay, we have to unmultiply x squared minus 3x minus 10. How do you do it? Okay, you start with 2 parentheses. Check, we've just done it. Number 3, the front factors of both parentheses are going to be factors of, I'm just trying to focus you, you don't have to do that, of x squared. So we have to choose 2 things that multiply together to give you an x squared. Not a whole lot of choices for this one. That's good. There's only one choice. Well, there's 2. You could do x squared and 1, or you could do x times x. Those are 2 choices. It's almost always x times x. So I'm going to go in my first try. I'm going to put an x in the front of the front, and I'm going to put an x in the front of the back binomial. Again, by the way, I'm going to write in black here. This is our first try. Because remember, this is trial and error. But again, if we have some knowledge, we can cut down the number of trials. Okay, we got half of the problem done. Now we got to figure out what goes in the back of each parentheses. And here's the key. The back of each parentheses is going to be factors of the back number. Right? By the way, the front was factors, I should have done this, of the front number, right? The back is factors of the back number. So I have to come up with factors of -10. So that should be green. Somebody give me one set of factors that give me -10. Wesley? Not quite. Matt? 2 and -5. So there's one possibility. 2 times -5 equals a -10. Somebody give me a different pair. Justin? All right, that is a different pair. -2 times 5 is a different possibility. There are a couple more. Somebody give me another one. Gabby? A -10 times a 1 is another possibility. And what's the last one, Kyle? And a 10 times a -1 is the last one. This one gives you 4 possible sets. Depending on the back number, you could have 8 or 12 or 20 possible sets. Hey, 20 sets, a lot of keys, right? And we're going to try to give you ones in the beginning that don't have a lot of possibilities. So we got 4 shots here. And I got to decide, do I want to use 2 -5, -2 5, -10 1, 10 -1. Now I got news for you. One of those is correct and the other 3 are wrong. Though all 4 equal -10. One of them's correct and the other 3 are wrong. So how do you know which one? How are you going to know which one? How are you going to know which one? How are you going to know which one? The key is the middle term. How are you going to know which one? Which one gives us a -3x in the middle? All right, so we need to figure out, we got to take a stab here. We got to try our first try. Attanel, which of the 4 do you want to try? All right, Attanel says first try. In green, put a -2 and the +5 in. It's our first try. We've got to do our check, folks. We got to do our check. Take your green, multiply the outers. We already know the first thing is correct. X times x is x squared. What's our outers? X times 5 is a 5x. Now do the inners. That should be red. -2 times x is a -2x. What does this equal? Write it in blue. What does this equal? A positive 3x. Does that match the middle? Wrong pair. Wrong key. You use the wrong, hold on, just hold on, guys. You use the wrong key. That's okay. You might use the wrong key. First try. Bloop. We got to do a second try. Thank you, Attanel. I was hoping we wouldn't have it correct on the first shot. Although we are going to learn. Hey, what do you do second time? Two parentheses. What does the front have to be? Thankfully, on this kind, there's only one possibility. Relax. X and X. And now we're back again to a second pair. And by the way, let me come back here and cross off octanels -2 and 5 because that didn't work. All right, they're gone. Didn't work. Again, look below. You must pick the correct factors that produce the -3x in the middle. You got to pick the correct ones. Only one of the four gives you a -3x in the middle. Quinn, which ones you want to use next? The +2. By the way, that's a +2, and you need the positive sign, and the -5. So again, what's our check? The outer times the outer is now a -5. The inner times the inner is a +2x. In blue, what does that equal? A -3x. Yes. Yes, there's my answer. X squared minus 3x minus 10 factors into the quantity x plus 2 times the quantity x minus 5. And by the way, commutative property. Could we have said x minus 5 times an x plus 2? Could we have said it? Could we switch to two parentheses? We could, as long as the 2 is positive and the 5 is negative, right? The order can change, commutative property. So you may have said x minus 5 times x plus 2. Not a problem. That's the exact same thing, commutative property. Questions so far? Wesley.
Can't you just do the first parentheses, take 2x, and then the second parentheses do -5x? Just like add them together.
Okay. Hold on. Don't write this. First parentheses, what do you want?
No, I'm saying like you just take the parentheses that are already there and just like add the 2 with the x and put 2x and then add 5.
What? Okay, hold on. What parentheses where? These or here? What are you talking about? Second try. Why don't I just do what?
Put the x after the number and then put it down below.
What x after the number? After this number?
Yeah, like
Yeah, is that what you're saying?
Yeah.
That with that and that with that? That is not a okay. You're not actually doing the math. It seems like a shortcut, Wesley, that does work on this simplistic kind, but only works on this simplistic kind. Because it's a shortcut that isn't even really a shortcut. It's just an abnormality that happens to seemingly work. Because that's not really what's going on. How do you really multiply two binomials? Front times front, front times back, that's part of our check. Back times front, that's the second part of our check, and back times back. And nowhere do you do the thing times the same thing in the middle. So it seems like it works. Good thought. At least you're looking for patterns, but it's not a right pattern. Okay? Let's go on to the next one. Next page. Let me do it like this. All right, so our next example, n squared minus 6n plus 8. Number one, look to factor out common factors first. How many of you are going to forget that? Numbers of you. Don't forget it. Are there any common factors, yes or no? All right, so none. But I checked. Somebody tell me what to do next. Wesley. Two parentheses. I'm going to put them in black. This is going to be our first try. But you know what? Should be our last try. All right, two parentheses. Next, you guys already have it on your paper. Remember, the front implies factors of the front. The front is an n squared. So, Sam, what are our front factors going to be? N times n, right? That's what I think you meant. And I agree. We're going to have an n in the front, right? Because doesn't n times n equal the n squared? All right. So a red n in the front of the first one, a red n in the front of the second one. Now we got to go to the back and figure out factors of the back term. We have a positive 8. All right, somebody start giving me factors of positive 8. Quinn? Okay, we got a 2 times 4. I agree. Zach, say again? Same thing on this one. So the order is okay, doesn't matter. John? Okay, we also have a negative 2 times a negative 4. All right, what else? There are others. Eva? 8 times 1, which is the same as 1 times 8. And what else? Gabe? All right, and we'll just stay the same order, negative 8 times negative 1, same thing. Okay, I think that's it. We have 4 possibilities. 4 possibilities. Okay, how do you keep from wasting your time with the keys? The way you keep from wasting your time with the tries is notice the Ford keys, notice the Nissan keys, and don't try them. In other words, this is the key now to everything. Here's how I do the problem. Before I'm ever going to write anything down, I'm already looking at the outers. And I'm saying to myself, what happens if I put a positive 4 as an outer? I got to put another positive number as the inner. Will that ever give me a negative 6n in the middle? I can only use positive and positive, right? By the way, I can't use a positive times a negative. Does a positive times a negative equal positive 8? No, I can't use them. Remember, the back two have to multiply to positive 8. So you know what? I just figured out none of my positive ones are going to work. Because that's going to make the middle a positive number, and that doesn't work. Because, guys, listen, the whole time I'm trying to figure it out, I'm looking at the middle. I'm looking at the middle. I'm looking at the middle. Because isn't the middle our key? Isn't the middle our check? See, I'm really doing the check in the midst of picking my factors. So I'm thinking, all right, what will I put in the back with its pair that will then go in the middle that's going to give me a negative 6n? And if you think ahead, you'll do it in one try. Go ahead, think it through. You're looking at your front times front, your outers. Your middle times middle, your inners. Add them up. Which one gives you a negative 6n? You got your pair? Say it on 3. 1, 2, 3. There you go. First try, right? First try. Because I'm thinking of the check when I'm making my choice. So again, here's the check, but I already know I'm right? N times negative 4 is a negative 4n. Negative 2 inners times n is a negative 2n. And sure enough, that's my middle. Did it in the first try. Follow? Wesley. You got to make sure you pick the right pair. And it's I got to tell you, okay, I think your question is more, do you have to show this? No. You don't have to show it, but you better be doing it. Otherwise, you're going to have probably the wrong pair. All right? You don't have to show it, but you got to be doing it. I mean, you got to be doing it. So remember, folks, the answer is this. Quantity n minus 2 times the quantity n minus 4. That's our answer. That's the factoring, the unmultiplying of the n squared minus 6n plus 8. All right, let's go on to the next one. Oh, boy, there we are again. Look to factor out common factors first. Any common factors? Oh, yeah, you better. You better. I don't know about you. I'm going to do it in red. I see a common 3. And do not skip this step. Do not skip this step. Do not skip this step. Is that clear enough? Why do you think I said that 3 times?
Power 3.
1, it's important, and 2, dumb, stupid students don't show this step. Dumb and stupid? Yeah, dumb and stupid. Because I keep telling them this, don't skip the step, and they skip it anyhow. Am I calling them dumb because of their IQ? No, I'm calling them dumb because of their actions. It has nothing to do with how smart they are. Nothing to do with how smart they are. Nothing to do with how smart they are. It has to do with their actions. It's a dumb action. Don't skip this step of the factored out common factor. Let's use our color. Would you agree I have a red x squared left in the front? Somebody tell me what's in the middle. What's left in the middle? 3x, a positive 3x, right? Positive 3x. Josh, what's left in the back? Negative 10, right? Do you agree we took out a common 3 from every term? Remember, less than 1, factor out common factors? Okay. We had to that time. Now we're right back to, what would be next? Somebody raise their hand, tell me what's next. John? What's next? Dave, what's next? What's next? Rachel, what's next? 2 parentheses. Now, look, guys, don't forget about that 3 out front. It's still there. It's got to stay out front. And it'll be out front in your final answer, okay? Some students forget it. They factor it out, and then it's like it disappeared. Remember, it's still out there, right? It's still a multiplier. Don't forget it. Be careful there. Okay, 2 parentheses. Gee, I don't know how you'd even know to say that next. It was on the right-hand side of your notes. In black, it said, number 2, make 2 parentheses. And, of course, what's next? Front is going to be factors of the front. Oh, I didn't list our front this time. Everybody look at the board now. Don't do this in your notes. Why did we need this step? Because this is the front we are using, and this is the back we are using, and this is the middle we're going for. You need that step. All right? You need that step. Students still don't put it. Again, because they're dumb. I'm just telling you, they're dumb. All right, so our front's got to be factors of x squared, right? Agreed? And again, thankfully, that's the easy one. It's got to be x times x, right? There are no other possibilities. By the way, tomorrow we'll see other possibilities. Oh, yeah. Monday we will see other possibilities. I could make that happen. You never know. All right, x times x. The back, remember, factors of the back are going to be factors of what? Say it if you know it. Negative 10, not 10, negative 10. It's got to be negative 10, folks. Okay, so again, the only reason I'm listing all the possibilities is so you'll be thinking all the possibilities. But again, I usually do them in my head. But what are the possibilities? Negative 1 times 10. 1 times negative 10. Negative 2 times 5. 2 times negative 5. Right? Those are my choices. All right, don't miss this now. Don't miss this. Just one more time. How do I make my choice? I always think what I'm going to put in the back because it's the outers. And I'm always thinking the front times the back gives me how much toward my 3x in the middle, right? Right? What's my middle? A positive 3x. Remember, what am I going for? A positive 3x. So my x times which of these gives me a shot of a positive 3x when I also add the middle, put the other one in the middle with the middle times the middle. So let me give you about 10 seconds. Cycle through that thought process. Outer times outer plus inner times inner. Which pair gives you a positive 3x in the middle? Which one gives you positive 3x in the middle? Cycle through. Think it through, and you'll cut down on your attempts instead of blindly attempting. All right, on 3, tell me your pair. 1, 2, 3. Negative 2 times a positive 5 is the only set of factors. So Wesley, you just proved that for you, you better physically do the check. I'm just telling you, I'm trying to help you personally. You better physically do the check because you picked the wrong ones in your head. X times a positive 5 is a positive 5x. Negative 2 times a positive x is a negative 2x. This is the only pair that yields a positive 3x, which is our middle. Final answer, 3 times the quantity x minus 2 times the quantity x plus 5. Again, I'm not trying to be derogatory, Wesley. I'm just trying to help you. You came up with the wrong pair, and that'll happen. Even though you thought it through. It was the wrong one. John? No. Nope. That is an impossibility unless you didn't factor out all the common factors. If you don't factor out the common factors, you might find something that seemingly looks right. Well, you're a bum if you don't factor out common factors, but yeah, it's that idea, right? You're still not completely factored. It'd be like, here's an analogy, John. Let's say you have the number 20, and I say factor it to prime numbers, and you say 4 times 5. Is it prime? Because the 4 is 2 times 2. That's the exact analogy. If you don't factor out common factors first, you can get 2 binomials, but there's some more factoring out of the 2 binomials. Okay? All right, let's do the last one here. Are there any common factors? Yes or no? Don't skip the step of showing it. Take out the common 2. Keep your front term red. It's an a squared. Keep your middle term in blue. It's a negative 6ab. Keep your back term in green, a positive 9b squared. All right, I got to kick it into higher gear here for time's sake. Get rid of my shade here. So, make 2 parentheses. Remember, do not forget the 2 out front. 2 parentheses. All right, remember now, my front is an a squared, so I'm doing a and a, right? It's an easy one. My back is a positive 9b squared. All right, real quick, possibilities. 9b times b, or 1b, right? That gives me a positive 9b squared. Negative 9b times negative 1b. And again, negative b, negative 1b the same. Positive 3b times positive 3b gives me a 9b squared. And a negative 3b times a negative 3b gives me a positive 9b squared. Do you have to show all these choices? No, but you have to think them, right? You got to think them. I'm showing them because I'm trying to teach you what to do. I'm trying to show you what your thoughts should be. So one last time. What's the key to picking the correct pair right off the bat? You got to be thinking a outer times whatever one I choose in the back. And then, that should have been green, right? A outer times back outer plus the inner times the inner better give me a negative 6ab. Which ones gives you a negative 6? That's your choice, right? So that's what you're thinking. Outer times outer plus inner times inner, which gives me a negative 6ab. I'll give you a minute. See if you can find the right pair. Think it through. Everybody thinking. Oh, by the way, down here, remember, you must pick the correct factors that produce negative 6ab, right? That's what you're after, that middle. All right, on 3. Give me your choice. 1, 2, 3. Negative 3b, negative 3b. Please take note how we're going to write the final answer on this. By the way, the check and for time's sake, I'm not going to write it. You get a negative 3ab and another negative 3ab for a total of negative 6ab, the correct middle, right? How many got it right? I heard a bunch of you. All right. Now, notice this one. We're going to write our final answer like this. Do you see how both parentheses are exactly the same? So therefore, we're going to write that final parenthesis squared. Right? Does it make sense? That's the way you write a final answer if both parentheses are the same. What does squared mean? The base times itself 2 times, right? It's a simplified form. Hey guys, just hold on for a minute. You already know the homework because it's written on your sheet, but I need to finish the class, so just hold on a second. Gone. Say again? That's everything that can possibly come out. We factor completely. There's nothing more. What about it? There was nothing more we could get out. The 2 was the only common factor. You get everything out in the first thing, yes. All right, you're dismissed.